Ever wonder how raw steel becomes the sharpest blade in your home? Let's go inside the factory. Thinner than paper, but sharp enough to split a hair. Watch exactly how this blade is made.
The journey of the world's sharpest blade begins here, in a massive warehouse holding tons of premium.
This is cold-rolled steel. It is thin, flexible, but incredibly strong. A heavy-duty forklift. The coil is loaded onto the decoiler machine. It starts spinning slowly, feeding the steel strip.
Before cutting, the steel must be perfectly flat. Heavy rollers compress the strip with immense force to remove any bends, curves, or imperfections. The strip now enters the heart of the operation, the high-speed stamping press. This mechanical beast exerts.
Inside, a carbide die punches the steel with extreme force. It happens too fast for the human eye, creating the blade's shape in a fraction of a second.
As the shape is cut, tiny pieces of excess metal fall away. These scraps are not wasted.
The result is a continuous strip of blades. You can now see the iconic keyhole shape in the center, perfectly defined and repeating endlessly.
This machine produces over 800 blade blanks every single minute. It is a symphony of speed and precision, moving so fast it becomes a blur.
The stamped strip isn't cut into single blades just yet. It is wound back onto a new reel, creating a perforated.
Soft steel cannot hold a sharp edge. So, the strip enters a massive industrial furnace, heated to over 1100 degrees Celsius.
Inside, the extreme heat changes the steel's molecular structure. Watch the silver metal turn a glowing cherry red.
To lock in the hardness, the red-hot steel is cooled instantly. This thermal shock is called quenching.
It gets even colder. A cryogenic freezer chills the blades to -70 degrees Celsius to freeze the atoms in place.
The steel is now incredibly hard, but also brittle. A second, gentler oven tempers it, making it flexible enough not to snap.
Quality check. A machine performs a bend test to ensure the steel is tough but won't break under pressure.
Before sharpening, we brand the blades. A high-speed laser etches the logo and text onto every single blank.
The laser burns the surface with incredible precision. It marks hundreds of blades per minute without slowing down.
An optical sensor scans the printing. If a logo is faded or crooked, the machine flags it instantly.
The hardened, branded strip is now ready. It moves to the next station for the most critical step, grinding the edge. Now, the most critical step. The hardened steel strip enters the grinding station to be sharpened.
3 sets of rotating stones carve the edge. First coarse, then medium, then ultra-fine.
The first wheel is rough. It grinds away the bulk of the metal, creating a shower of sparks. Friction creates immense heat. To prevent warping, a milky white coolant floods the grinding zone.
The final wheels are delicate. They hone the tip to a microscopic point, removing all scratches.
This process creates the Gothic arch angle, a shape that balances extreme sharpness with durability.
To finish the edge, the strip passes through rotating leather discs, just like a barber's strap.
The grinding leaves the blades dirty. High-pressure water jets blast away oil, grit, and steel dust.
Air knives blow the remaining water off the surface, leaving the blades perfectly dry and spotless.
A high-tech camera inspects the edge. Even a microscopic chip will cause the machine to reject the blade. The long continuous strip is finally snapped into individual blades by a high-speed breaker machine. A magnetic rail catches each falling blade, stacking them perfectly aligned, one by one. To coat the edges evenly, thousands of blades are loaded onto long metal skewers. Stainless steel is sharp, but drags on skin. We need a high-tech coating to reduce friction.
The stacks enter a massive vacuum chamber. The air is sucked out to create a deep space void. Inside, We blast the edges with chromium and platinum using glowing purple plasma. This creates a nano layer hard enough to keep the edge sharp, shave after shave. Finally, a fine mist of Teflon is sprayed onto the edges for the ultimate smooth glide.
The blades travel through a tunnel oven to bake and cure the Teflon onto the metal. Now coated, the blades are smoother than glass. Nothing can stick to this surface.
The result is a masterpiece of engineering. Thinner than a hair, harder than sapphire.
This is the safety razor blade, the ultimate tool for a perfect, classic shave.
Precision is everything. Before packaging, random blades are taken to the lab for the thread cutting test. Under an electron microscope, the edge is magnified 2,000 times. It must be smoother than a mirror. We also check the grinding angle. A laser scanner ensures the Gothic arch shape is mathematically perfect. Durability is key. The Vickers test presses a diamond tip into the steel to prove it is hard enough.
To test for rust resistance, blades are exposed to corrosive salt steam for 24 hours.
Not a single piece of metal is wasted. The scraps from the stamping process are collected here. A hydraulic press crushes the loose steel scraps into dense, heavy cubes for recycling.
The coolant liquid used in grinding is also filtered and recycled to protect the environment.
Every shift, the grinding wheels are dressed and cleaned to maintain micrometer precision.
The finished blades are removed from the coating racks and fed into the high-speed packaging line.
Wax paper is used to protect the sharp edges. The machine cuts the paper from a massive roll.
Watch the precision. The machine folds the paper around the blade like instant origami.
A single dot of glue seals the envelope. No human hands have touched the blade so far.
The wrapped blades are grouped into sets of 5 and pushed into small cardboard tuck boxes.
To keep moisture out, each tuck box is wrapped in clear cellophane and heat sealed.
Robots pack the small boxes into larger retail cartons, ready for shipping. From raw steel to a world-class product, pallets are loaded onto trucks for global delivery.
Only when the batch passes every single test, the green light is given for packaging.
The packaged blades travel to the logistics center. Robots stack the cartons onto wooden pallets with perfect geometric precision.
To ensure stability during transport, the entire pallet is wrapped in layers of clear plastic film.
Forklifts move the ready pallets into the massive high bay storage. Millions of blades wait here for dispatch.
Morning arrives. The loading docks open, and the fleet of transport trucks backs in to receive the cargo.
From the factory floor to the highway, these blades are now on their way to supermarkets and barbershops worldwide.
Finally, the destination. A customer opens the box. The wax paper wrapper protects the blade until this very moment. The blade is loaded into the razor. It fits perfectly. A satisfying mechanical click confirms it is ready.
The moment of truth. The blade glides over the skin, cutting hair effortlessly without any irritation.
Engineered for perfection. Thinner than a hair, harder than sapphire, and smoother than silk.
This is the double-edged safety razor. Old school engineering, modern precision, made to last.